All right, so 1.7 is about different translations, transformations, including translations. Okay, and we're going to apply the transformations to graphs of functions. What transformations do you guys remember doing in geometry? You can just yell them at me. Reflection, rotation, translation, yay. Yes, which is the dilation, and in Algebra 2, we call that a stretch or compression. And we actually are not going to worry about the rotations, but we are going to do the reflections and the translations today. Okay, we're also going to do compositions of those, which just means we're combining them together. So we can have different transformations, one right after the other. Okay, so last week we talked about families, parent functions. A family of graphs is going to have graphs and equations that have a characteristic in common. And we know that the parent graph is transformed to create the other members in a family. Aww. And the parent function is the simplest function. Okay, so it's the simplest function in your family. Okay, so here are the 4 different families we're going to focus on. The first one is a constant function. This is rare, but we did see some of those when we were graphing inequalities. So it's something like y equals c, where c is a constant term, and that just means any number. Also in the description here, they show them to you in function notation. So f of x equals a is another way you might see that. And a is just any number. Okay, they call this the identity function. We are not going to call it that. It is the linear function. Okay, and we know that the most basic linear function is y equals x. It has a slope of 1 and a y-intercept of 0. Okay, eventually we are going to move to all of the function notation. Okay, but we're going to kind of ease you into some of that. We talked about the absolute value last week and that parent function. So when you do the absolute value, you just have y equals the absolute value of x. And the quadratic is y equals x squared. Now with the quadratic and the absolute value, remember they both have a vertex. And this vertex we call H and K. Have you guys ever heard that before? Okay. So those are just the 2 variables that we use, and it's the same thing with this. Your vertex is going to be H and K. So we're going to be relating that to different equations. And a translation is probably one of the most popular types of transformations. It is when you slide a figure from one position to another, and it's not turned and it's not getting larger. Okay, and there are really 2 types of translations. You're either going to move the graph up or down, or left or right. Okay, so we're going to have some different rules, the translation rules. So if you are moving a graph up or down, they call the function f of x. And what tells you whether it's up or down is if you have something added or sometimes subtracted to the outside. So if the k value is positive, right, greater than 0 means positive, that means the graph is going to move up. If the k value is negative, which means it's less than 0, it's going to be moving down. So you'll be given equations and you'll have to say where they're being moved. Okay, so up and down is usually the simpler of the 2. The next one is left and right. Okay, and then this is the rule, f of x minus h. Okay, so the difference here is up and down is something that's vertical, so it's outside. Left and right is something that's horizontal, so it's applied directly to this x value, which is the independent variable. Notice here that you have a minus. So this can mean minus, it can mean subtraction, or it can mean the opposite. So when you have a function where it's the opposite, if your h value is positive, okay, if you do minus a positive, all you're going to see is the negative in there. I'm going to show you an example. So if your h value is positive, we know the graph is going to be moving to the right. Okay, so if your h value is positive, your function is going to look like this. It's just going to be x minus h. Because if your h value was 5 and you plugged in 5, you have x minus 5. But if your h value was negative, okay, then your graph would be going to the left. So if it's a negative and I'm plugging it in, if I have a negative h, I have x minus a negative h. How do you simplify minus a negative? It's going to be plus. So when you're looking at the function, it's really going to be addition. But when you pull it out, it's minus the negative. So we know if it's a negative, it's going to the left. We're just going to have to do the opposite of what we see there. So that can be a little tricky. I'll also show you some examples on Desmos so that you can see what's happening to your graph. All right, and then we have equations for standard form for the absolute value and for the quadratic. This book calls this standard form. We also call this vertex form because you can pick that out. You can pick out the vertex by just looking at the equation. So when you have to write equations, you're going to have to write them in standard form. So it's f of x equals x minus h squared plus k. So in that case, your vertex is h comma k. So again, notice this is the opposite of what you see. And the vertex always tells you whether you're going left or right for the h, and then up and down for the k. And then your absolute value is also going to follow a similar equation. So your absolute value is f of x equals x minus h plus k. All right, I know that was a lot of information. We are going to be applying it to our equations in example 1. So notice in example 1, the directions say, describe each translation as it relates to the graph of the parent function. When they say describe, you are going to be writing a sentence. Okay, just one sentence. And anytime they're asking you to relate it to the parent function, you have to include the equation. Okay, you have to include your equation. Okay, so when you're looking at the function y equals x plus 5, you just have to determine, is that a constant, is it linear, quadratic, absolute value? So what is A? Linear, quadratic, absolute value? Linear, right? It can't be absolute value. We don't have the absolute value symbol. Can't be quadratic. It's not a power of 2. Okay, so this is going to be a linear function. And anytime it's a linear, you only have to worry about if it's going up or down. Okay, so you'll have this plus 5. So because it's on the outside there, and the k value is greater than 0, it means that we are moving up. Okay, so we would just say y equals x, that's the parent function, is translated, and you can say up 5 units, or you can say 5 units up, but that is going to be your answer. Okay, now for B, do we know what the parent function is? Yeah, quadratic. You have the square. Okay, so if it's quadratic, that lets us know what we're working with. And then we have this plus 9. Is that the H or the K? If it's inside, it's your H. And then remember, if you have a plus, that's because you had minus negative 9. So it's the opposite of what you see. So again, we're just basing that on our equation here, right? So if you have x plus h, it's because you had minus a negative here. Okay, so that means the parent function is translated 9 units where? To the left. Good. So y equals x squared is translated left 9 units. Okay, now C has 2 transformations, and hopefully we notice right away it's the absolute value, right? So we know that we're going to start with y equals the absolute value of x is translated. Okay, and then I'm going to give you a minute to fill that in. So like I said, there's going to be 2 of them. Okay, and we'll see if we got those right. I'm going to put up on the board the decimals. So start watching the video on next week, kind of see what the absolute value is. But we have your V shape here, and then we're going to do the absolute value of x minus 4. So where did the minus 4 take the graph? 4 units to the right. So can you guys see that up there? Okay, and then we also have the minus 2, which moved it down. So again, I know the negative sometimes confuses people. Okay, it's because when you're looking at your equation, you already have a negative in there. So that is the opposite of what you see. Okay, so this means it's translated 4 units right. And on the outside, this is your H is 4, this is your K is negative 2. So it's 2 units down. And you can also think of it like your vertex, right? If it's positive, it's right, negative, down. And then when you're doing your homework, you don't have to write out these notes. This is just so you know where this is coming from. Okay, so you can use that to just write your sentence out. All right, and then the next thing we're going to do is use the graph of each translated parent function to write its equation. If directions are telling you to write an equation, what should you have in your answer? An equal sign. Yes, a y equals. Okay. Yep, so you could have either y equals or you can have f of x equals. We'll do one of each. Okay, so if you don't have an equal sign, it's not an equation, so you have to make sure you have that. Now we can decide what the parent function is based on the shape of the graph, because if it's a U shape, we know it's what? It's quadratic. Y equals x squared.
Right, the parent function equation.
No, we're going to do the translated one. Yep. So you have your parent function, and then we're going to use that standard equation that we wrote down on the first page, which is for a quadratic. It's y equals x minus h squared plus k. And then we're just going to use our vertex to plug in for our h and our k. Okay, so here's our vertex. In this case, the vertex is also the y-intercept. That doesn't always happen. This time it does. Okay, so if I take my vertex and I plug in my h and my k, I will have x minus 0 squared plus 5. And then if this is a 0, you can simplify it. X minus nothing is still x. And then x squared, you can write out. And so this is your final answer. So again, when you're doing this on your homework, you can see what the vertex is. You'll be able to plug that in right away. So for ones like this, you can jump right there. That's perfectly fine. All right, and then B, we have absolute value, which is very similar to our quadratic. So we have to pick out our vertex. Okay, because it's the V shape, we know it's the absolute value. And so we can use the absolute value standard equation. Okay, and then your vertex is over. These are going by 2's. So what's my x coordinate for my h value? For my vertex? -3, yeah. And then your k value, great. All right, so then when we plug that in, remember, you have minus a negative here. And, oops, sorry, the absolute value. And then this is plus a negative. So the way that we write that, and again, most of you are just going to jump there, minus a negative becomes a positive. Plus a negative is just minus. Okay, so this should be your simplified equation. Okay, so once you see it's negative, you know that's positive here. The outside will always stay whatever the same symbol is. All right, any questions for me up there? All right, let's talk about dilations and reflections. So a dilation is something that either stretches or compresses the graph. And when you stretch or compress, it's either going to be like a vertical stretch or a horizontal stretch. And what happens is the graph gets narrower or wider. Okay, so these are things that make the graph either narrower or wider, just depending on what transformation you have. Okay, so there's really 4 different types within here. So if you multiply a function by a constant, that is going to dilate the graph with respect to the y-axis. So if you multiply a function by a constant, that dilates the graph with respect to the y-axis. And if you were looking at that as an equation, it would look like this. you would be multiplying a function by some value of a, which we call the constant. Now the other type you can have is when you multiply the independent variable by the constant, and that dilates the graph with respect to the x-axis. Okay, so notice where the constant is here. Okay, so here the constant is inside the function, it's being applied there. Here the constant is outside of the function. It's actually very similar to what we did for the even and the odds. I actually still have them on the board over there. See how the negative was on the outside versus the inside? Okay, so when you have constant terms, not one, that will either make the graph narrower or wider. And we saw that last week too when we were doing our absolute value graphs. So if there's two types, you have vertical and you have horizontal. So the first type is a vertical stretch or compression. Okay, and then if you have a vertical stretch or compression, the rule is the constant gets multiplied by the function. So the constant gets multiplied by the whole function. You can see it's outside of the function here. And then, based on the value of a, it's either a stretch or a compression. So if the absolute value of a is greater than 1, that is called a vertical stretch. If the absolute value of a is greater than 1, that is called a vertical stretch. And if the absolute value of a is in between 0 and 1, that's when you have a vertical compression. So we take the absolute value because sometimes you might have a negative there. Can you guys think of some numbers that are between 0 and 1? Half? 5/8? 0.25? Yeah, good. And then a vertical stretch, what that means is vertical is up or down. So if you're stretching something vertically, what you're doing is you are pulling it from the top and the bottom. And then if it's a compression, you are compacting it, so you're pushing it. So a vertical stretch is going to make the graph narrower, and a vertical compression is going to make the graph wider. So we're just going to make a little note that if you have a stretch, okay, that is a pull of the graph. If you have a compression, that's when you push the graph together or compact it. Okay, and then
why did you clarify
because it could be, if it's absolute value, that's just going to make it positive. So like if you have a negative 2/5 out there, right, the negative 2/5 wouldn't be between 0 and 1, but the absolute value would be.
So why did you clarify? It's less than 1 is the absolute value.
No, if you had something like this, so you might have like negative 2/5 x squared like that. So if you took negative 2/5, right, that wouldn't be greater than 0.
Well, but if we're going to put that in the absolute value,
yeah,
then
yeah.
it will always be greater than 0. So why did you clarify?
Oh, because it could be 5 halves like this. It could be like that, and then it wouldn't be. So if you took the absolute value of this, the 5/2, it would be greater than 0, but it's not less than 1. Oh, you just don't like the 0.
I just don't understand
Oh, it's there just so that you know it can't be negative. And you're saying because you're doing the absolute value of that. Yeah. It's there just so if you take the negative that you have that. Sorry, I kind of misunderstood it. Okay, and then the next one is horizontal. So a horizontal stretch or compression has rules that get flipped. Okay, so your rule would be f of a times x and then this is going to be the opposite of what happens vertically. So if the absolute value of a is greater than 1, then you're going to have a horizontal, and I did abbreviate. Write it out in the next one. So you have a horizontal compression, not that one. And yeah, for this one, sometimes I even just write it like this. Sometimes I write it without the absolute value. That's exactly how you see it in your book, though. Your a values between your 0 and 1. So if you want to write it like that, I'm fine with that. And that is a horizontal stretch. Okay, so because it's being applied directly to the x value, that is what changes these, what flips those. Okay, and then like I said, you can leave it like that. You can also put it in the absolute value. Your negative is going to represent a reflection. And so I usually talk about those separately anyway, which is the next rule. And the next rule we will talk about today okay, so a reflection is a transformation where you have that flip. Okay, so the reflection is where you have a flip over the line of reflection. And a lot of times it is the X or the Y, but it doesn't have to be. Okay, so a lot of times we've seen that as our line of reflection, but it doesn't have to be that line. Now these are going to look exactly like what we did the other day. So if you have a parent function multiplied by -1, negative f of x is a reflection of the graph. It says in the y-axis, we're going to say over, or sorry, in the x-axis, we're going to say over. So if you have a negative multiplied by the function, you are going to tell me that that is a reflection over the x-axis. Did you guys talk about that last year in geometry? You did with the equations? I know you talked about the reflections. And then f of negative x is a reflection of the graph over the y-axis. So again, these are just like our even and odd rules that we are proving. Okay, and sometimes I think these rules can be hard to remember, especially if you're taking a quiz over a bunch of things. So I came up with little ways that I remember them, and you can use these ways if you want. You can come up with your own. But when I was growing up and my mom would like write me cards, she'd always sign it XO, XO, Mumsy. So I think of XO, XO. Do you guys know what that means, like hugs and kisses? Okay. So what I think of this is, oh, if it's over the x-axis, the negative is on the outside. So if the negative is outside, it's over x, XO, XO. And then I remember if it's a Y, it's inside because Y and I, they rhyme. So that's how I remember. If I'm ever second guessing myself, I say Y rhymes with I, the negative's inside, so that's what it has to be. Okay, so you're welcome to use my tricks. You're welcome to just memorize them. You can do whatever works best for you. Okay, so for our next set, again, we have this word describe. So we have to describe each dilation and reflection. And then we are going to relate it to the parent function. So describe means we're going to be doing some writing. The higher you get in math, the more you have to write in math. I'm sorry to be the one that has to break that to you. Okay, and then the parent functions we're focusing on are the linear parent function, the quadratic, and the absolute value. And so those are going to be included in our explanations. Okay, so I'm going to write some notes on the equations to help you determine how to write them out. So I want you to write them down with me for this. So the first thing we're going to look at is the negative and that placement. Okay, so the negative is outside. And that's really what you want to know, is the negative outside or inside. So if the negative is outside, it's a reflection over x. Okay, and again, once you notice it's the absolute value, you can always start what you're going to say. Okay, so y equals absolute value of x is reflected over the x-axis. And then there's one more part that we're going to do, and that is this 2 on the outside. Okay, so if the constant is on the outside, that is our rule, a times f of x. And that lets me know it's going to be something happening vertically. So I just have to determine if it's being vertically stretched or compressed. So we just look at the number 2, and if 2 is greater than 1, we know it's going to be a what? A stretch or a compression? A stretch. So we're going to say y equals the absolute value of x is reflected over the x-axis and is vertically stretched. You can also say stretched vertically, that is fine. Okay, and then when you're doing this on your homework, you don't have to write these notes down. This is just to help you so you can see, like, where did this information come from? What is the thought process? This is what you should be thinking about in your head. Like for the horizontal, yeah, but like these I want you to write out. Or like for, what's that? No, write that out. All you have to write is one sentence. Okay, and then again, so we're going to start with the negative. So we just analyze where that negative is. Okay, so this time the negative is inside. Okay, so I know that that's going to be reflected over y. And then my constant is inside. Which means something is happening horizontally. And then I just have to decide if it's a stretch or compression. So we just have to compare 2 to 1. Is 2 greater than 1? Yes. So in this case, that means it is a compression. Okay, so when we form our sentence, we just start with the parent function. So if you have the 2, your parent function is y equals x squared. And we just say it's reflected over the y-axis. And it is compressed horizontally. Again, you can also say it, and it is a horizontal compression. So those are really interchangeable. Okay, now the linear one can be confusing sometimes. With the linear function, you're never going to have parentheses. Okay, so everything is going to be on the outside. So the negative is outside. Okay, and then this is outside. All right, so based on those facts, I want you to write the sentence for C and D. Okay, and I'll walk around and teach you how, but I want you to give this one a try. So do both C and D. All right, and then we'll check C together. So we have the linear function y equals x is reflected over the x-axis and is compressed vertically, or you could say vertically compressed. And again, that's because you have the 1/4, right? So the 1/4 is in between 1 and 0. That's your absolute value. Okay, so did we notice that this was inside? This was also inside. So the negative inside means that you have a reflection. So it is reflected over the y-axis. And then the 2/3 is in between 0 and 1. So is that a horizontal stretch or compression? Which one? Let's check it. Right, so if it's in between, the horizontal is the stretch. All right, any questions for you there? All right, then the last thing we'll do is describe the transformation as it relates to the graph of your parent function. Okay, so let's identify the parent function for each of those because we know that's what we're going to start with, right? For A, it's what type of parent function? Linear, so we'll start with y equals x. For B, it's absolute value, great, and C is quadratic. So when you're deciding how many transformations there are, because some there'll be 2, some there'll be 3, maybe there's just 1 for some. It's all based on comparing these. So y equals x, I can see there's a 2 that's been added and then a 5. So those are the 2 things I'm going to have to describe. So anytime it's linear, remember it's outside. So if this is outside, it's a vertical stretch because 2 is bigger than 1. And then it's always up or down, so it's positive, so this is going to be up. So we just say y equals x is vertically stretched. And translated 5 units up. Right, now for B, don't treat this as a -4. We're going to do the negative separate because we know anytime there's a negative, there's a reflection. And then anytime you have a constant, it's either a vertical or a horizontal stretch or compression. So in this case, it's outside. So anytime it's outside, that represents something is happening vertically. Okay, and then you also have the -1. This is going to be your value for H. So if it's inside, what's your H value? 1. Good, +1. So it doesn't matter what order you put them in. I usually just go in the order they appear in your equation. So this is a reflection, so it's reflected over the x-axis. And then the 4 means that it's vertically stretched. And it's translated 1 unit up. Okay, so I'll give you a moment to do C. All right, let's see how we did. So the 2/3 is inside, which means something's happening horizontally. 5/2, is that greater than 1 or less than 1? Yep. And then you have the -2 on the outside, which means you're going to be going down. Okay, so this is compressed horizontally and translated two units down. Okay, so your assignment is not due until Wednesday because we're going to have time to work on it in class tomorrow as well as today.